Assalamualaikum and hello everyone. In this video, what we're going to learn is actually compare the atomic radius and its corresponding ionic radius. And besides that, we're going to define the term isoelectronic and compare the radius of isoelectronic species, and then analyze the variation of ionic radii across the period 2 and 3. So before this, we have learned about the atomic radii. Kali ni kita nak belajar tentang ion pula. Okay, so let's look on your notes. It will be on page 8. Okay, page 8 ni first tu adalah your transition element. Lepas tu kita akan tengok tentang ionic radii. For the ionic radii, what we're going to do is actually we're going to compare the ion itself. Ion tu we have our cation and anion with its neutral atom respectively. Okay, so let us look first for the cation. Okay, so cation ni is actually our positively charged ion. Okay, so how do we form cation daripada atom kita? Cation is formed when our atom donate the electron. Okay, so we will form our cation lah. Positively charged atom. Positively charged ion. Okay, so let us look for lithium. So di sini, dia bagi lithium. This is the number of proton. So the electronic configuration, since it is a neutral one, so electron dia sama dengan proton lah, which is 3. So the electronic configuration here is 1s2 2s1. Okay, that is for the atom itself. Tapi for the case of the ion, so remember, so kat sini actually memang proton dia 3, tapi number of electron dia sudah berubah kan? Sebab kita sudah donate one of the electron. So sebenarnya electron kita di sini tinggal 2 saja sebab we have donated one of our electron. So if the electron is 2, so right now the electronic configuration bukan lagi 1s2 2s1, dia sudah jadi 1s2. Okay, so sekarang ni we're going to compare about what is the ionic radii. What is the radii between the Li plus dengan Li yang neutral one. Okay, so yang sini kamu padamkan dulu di sini. Okay. So what happened here is actually first the number of the electron berkurang. So sebenarnya tulislah tambah di sini. Okay. Apa ni? So when the electron decrease, so maknanya sebenarnya the repulsion between electron decrease. Okay, so kenapa repulsion between electron ni decrease? Okay, so sebenarnya in our shell, we have our nucleus in the middle, but then we have our electron kan? All the electron ni semuanya adalah negatively charged. So when it is a negatively charged, semua ni there's a repulsion. So tadi sudah berkurang satu electron, so we have less of the repulsion itself lah. Okay, however, even though the repulsion decrease, sebenarnya for our case of our cation, dalam kes ni Li plus, it will actually have a higher ZEF, effective nuclear charge, than our neutral atom. Okay, yang ini sebenarnya senang mau tunjuk through calculation. Yang ini jangan risau, ni Miss akan explain through yang example sodium ni. It will be much more clearer to you lah. Okay, so when we're talking about effective nuclear charge tu maksud dia adalah kita punya from here. What we have here. Okay, kalau effective nuclear charge to increase, so maknanya adalah the positive charge, the one that do the nucleus fat lah. Okay. So if the effective nuclear charge increase, the attraction between the nucleus and the valence electron become stronger. So maknanya tadi kita sudah kata Li plus has a higher ZEF. Okay, so maknanya the attraction between the nucleus dengan valence electron for Li plus will increase juga. Okay, so bila attraction, contohnya between our nucleus, contohnya ada nucleus di tengah kan. So contohnya kita ada elektron di sini. So what will happen? So kalau elektron di sini dengan nucleus kita, attraction dia stronger. So what happen sebenarnya dia punya radius akan lagi kecil lah. Sebab our elektron tu suka lagi ke arah nucleus tu itself lah. The attraction tu. Kalau boleh mau dekat lagi. So the ionic radius will decrease. Hence, Li plus is smaller than our Li atom. So, bila kita tengok di sini, Li plus 60 picometer. Kalau Li 152. Again, why? Because satu, repulsion tu sudah decrease. Again, Li plus ni has a higher ZEF. Okay, higher ZEF ni maksudnya attraction between our electron di shell kita ni, di highest end kita ni dengan kita punya nukleus higher lah. So, maknanya dia mau lagi dekat. So, kalau lagi dekat, lagi kecil lah size dia. Okay. Next, sebenarnya kita senang tengok pada calculation dia kan. ZEF ni juga kita tengok pada sodium. So, for the case of electronic configuration of sodium, so sodium, kalau the neutral one, dia adalah 1s2, 2s2, 2p6, 3s1. Kalau Na+, okay, so maknanya we have donated 1 electron kan. So, electron dia sekarang ni tinggal 10. So, dia jadi 1s2, 2s2, 2p6. Okay, so sekarang ni kita mau kira ZEF. ZEF ni adalah Z minus dengan the inner electron. S ni ada again, dia adalah inner electron. Ataupun senang kita inner electron from the inner shell lah. Okay. So, for the case of Na ni, sebenarnya kiranya the outer shell adalah 3 ni kan. Ni yang highest end kita. So, the inner shell kita tu yang di mana? Adalah from 1s2 ni kepadalah sampai 2p6 ni. Okay. Okay. So, kalau for the case of Na+, inner shell kita, di sini tidak ada 3 kan? Tidak ada 3. So, yang kiranya, this is the valence shell kita. So, the inner one is actually this one. 1s2 ni. Okay. So, let us calculate ZEF. ZEF ni is actually the number of proton. Number of proton for this case, dua-dua number of proton dia adalah 11. 11. Okay, minus S kita di sini kita tengok. S kita kira di sini 2 plus 2, 4, 4 plus 6, 10. So, minus 10. So, kita dapat positive 1. Tapi kalau sodium ini, since sodium plus, these 2s2, 2p6 is the higher, the valence electron. So, maknanya the inner electron tu adalah 1s2 lah. So, sekarang ni, the inner shell, inner electron hanyalah 1s2. So, minus dengan 2, which is equal to positive 9. So, as we can see here, kalau kita ada positively charged, if we form our cation, hence we will have a higher ZEF lah. Okay. So, sini again, when we're comparing the radius, first we're going to compare is actually kita kena bagi tahu our cation has a higher ZEF than our sodium atom. So, if the ZEF is higher, so it means that the attraction between nucleus and valence to increase. Okay, again. So, maknanya kita punya elektron yang di luar tu lagi suka masuk ke dalam, lagi suka mendekat kepada kita punya nukleus lah. Hence, bila dia lagi dekat, kita punya ionic radii will decrease. Will decrease. Hence, Na plus is smaller than Na. Okay, so that is for the case of cation. Kalau cation ni, dia in terms of ZEF lah. Untuk kamu tidak perlu kira pun. Kira tu sebenarnya, kalau kira ni sebenarnya lagi mudah lah. Lagi mudah untuk kita nampak. Tapi kamu perlu tahu, for the cation, it will have a higher ZEF than our neutral atom. So that is for the case of our cation. Okay, so that is for the case for our cation. Now we're going to look at is for our anion. Anion is our negatively charged ion. It will form when the atom gain an electron lah. Okay, gain electron hence will be a negative one. Okay, so kalau kita punya 9F ataupun kita tengok case of 9F. Fluorine ni we have number of proton is 9. So when we write down 1s2, 2s2, 2p, 5. Okay. So that is actually kalau for a neutral one. Okay, so sekarang ni kalau F minus, okay, maknanya kita sudah donate ataupun we have gain 1 electron. So our electron now is not 9, sekarang ni electron kita sudah 10. So kita tengok, so it will become 1s2, 2s2, 2p6. Okay, so for the case of an ion, we will not compare the ZEF, we will compare in terms of electron itself lah. So, kita tengok berdasarkan sini, we can see that the F minus has more electron than F. So, what happen bila lagi banyak electron, so lagi banyaklah repulsion. So, kita tulis sini, the mutual repulsion between electron increase. Again, pada shell yang sama ni, pada setiap satu atom, kalau lagi banyak elektron, what will happen? Since it has the same charge, there's a repulsion lah. Okay, so bila ada repulsion, so maknanya the attraction, so it means that the attraction between the nucleus dengan valence electron akan decrease. Okay, sebab kita ada shell di sini kan, kita ada nukleus. So, maknanya bila elektron dengan elektron ni sendiri ada banyak, dia akan compete with each other lah. So, lagilah dia mau tolak. Dia mau tolak di sini. So, the attraction between our nucleus dengan valence electron ni, the attraction dia berkurang lah. Sebab ada repulsion between the electrons here. Between the electrons itself. Sini electron ni adanya repulsion. Okay, so what will happen? So, bila attraction decrease, the ionic radii pun akan increase. So, ionic radii will increase. Hence, the F minus is bigger lah. Sebab lebih banyak elektron, lebih banyak repulsion. So, attraction dia berkurang, lebih besar lah. Okay. So, kalau in terms of anion, we're going to compare in terms of electron. Kalau cation, kena compare dia in terms of ZEF. Okay, so the last one kita tengok for the case of chlorine. So, chlorine dia punya electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. Okay, kalau chlorine minus, elektron dia bukan lagi 17 sebab dia sudah gain satu elektron. Elektron dia adalah 18. So, dia adalah 1s2, 2s2, 2p6, 3s2, 3p6. So, again, when comparing case of an ion, kita kena bagi tahu Cl- has more electron. So, bila lagi banyak elektron, repulsion dia akan increase. So, bila repulsion increase, the attraction between kita punya nucleus dengan elektron yang paling duluan ni berkurang lah. Sebab ada competition di sini. Okay, so the attraction decrease. Hence, the ionic radii will increase. Hence, Cl- is bigger than Cl. Okay. So, again, for the case of ionic radii, kalau cation, dia makin lama, kalau lagi banyak, kita donate. Ataupun kalau kita donate elektron, dia makin kecil. Kalau kita gain elektron, okay, it will become bigger. Because we have the extra repulsion. Okay, so that is for the case of ionic radii. So that's just an overview about the ionic radii. So let's look for the case of isoelectronic species. About ion juga. Okay, so what is meant by isoelectronic species? Isoelectronic species ni means the atom or ion with the same electronic configuration. Okay, so kita tengok dekat sini. Kat sini kita punya proton number is actually sama 11, 12, 13, 14, 7, 8, 9. Okay. Lepas tu bila kita tengok, our sodium ni donate 1 electron, so jadi 10. Magnesium donate 2 electron, 10. Aluminium donate 3, 10. Ni pun 10. Okay. But this case, for our nitrogen, they accept 3 electron. So, ni pun 10 electron. Ni pun 10 electron. Okay. So, as we can see here, the number of electron is the same. So, when the number of electron is the same goes for the electronic configuration, which is 1s2, 2s2, 2p6. Okay. Okay, so this is what we call isoelectronic species. All the ion itself, okay, even though the number of protons is different, but the number of electron the same. So this is what we call isoelectronic species. Okay, ini just macam summary untuk kamu. The more positive the charge, the smaller the species. Okay, kenapa? Sebab maknanya the more positive the charge, maknanya dah donate more electron lah. Dah donate more electron. So, bila dah donate more electron, so it means that we have less electron. So, repulsion tu dah kurang, repulsion decreasing, so attraction to high, so that's why small the species. Tapi the more negative the charge, so maknanya dia gain electron dia banyak pula. Okay. Dan ni je summary tau. Gain electron, so bila dia gain more electron, maknanya kita have high number of electron lah. So, bila elektron banyak, repulsion tu is greater. The repulsion increase. So, that's why bila repulsion increase, the larger the species. Okay, tapi tak apa. Let's look for the examples itself for the explanation. So, from our sodium to our silicon, which is the element in period 3. Okay, so we know that this is actually the ion. Dia minta electronic configuration. Okay, so again, this is actually about our isoelectronic species, and it has donated the electrons. Donated the electrons itself. So it's actually 1s2, 2s2, 2p6 ni. So that is actually the electronic configuration number of electron. But then let's calculate the ZEF. Okay, what does it mean yang ZEF kat sini? ZEF ni, here is Z. Z is actually our proton number. Okay, Z ni is actually our proton number. Ni S ni inner electron. Okay, so in this case, this is actually our valence electron. This is valence kita. Hence, this is our inner electron. Ni inner. This green one is inner. Ni yang green yang ni lah. The one that I'm using. So, this is the inner electron. So, let's calculate the ZEF. Okay, remember Z ni is the proton number. Not the number of electron, the number of proton here. So, here it will become 11, 12, 13, 14. Okay, in this case, the inner electron kita is 2. So, 2, 2, 2, 2. Okay, make sure ni positive 9, positive 10, positive 11, positive 12. Okay, so let's explain here. So, for the case of sodium to our silicon, the proton number is actually increased. So, what happened is that the effective nuclear charge pun increase. So, when the effective nuclear charge increase, so the attraction between the nucleus and the valence electron itself will increase. Okay. So, what happened is that the ionic radii decrease. Okay, dalam case ni, we can look at the number case of ZEF lah. That's for the case of sodium to silicon. Okay, right now, kita dah discuss yang between these four. Right now, we're going to discuss between these three pula. For case of our anion. Okay, so again, ini pun electronic configuration dia sama juga. Dalam case ni, ZEF dia Z minus S. Okay, so dia punya ni 7, 8, 9. Minus, minus, minus. 2 is positive 5. Here is positive 6. Here is positive 7. Okay, so what does it mean here is that, okay, these ions are all the isoelectronic species and the proton number increase. Okay, between all the proton number ni pun increase juga starting from our nitrogen to our fluorine itself. Okay, so what happened here when we do the calculation, we can see that the effective nuclear charge increase. So what happened is that the attraction between nucleus and valence electron pun akan increase. Hence, the ionic radius decrease. Okay, so right now, let's look for the case. Yang ini is actually about ionic radii for Isoelectronic Species. So yang ini kita nak tengok Ionic Radii for period 2 and 3 pula. So kita tengok dekat sini. This is period 3 punya element. So again, this is actually what we have discussed previously from our sodium to silicon. So we know that this is all isoelectronic species. Ini sama je. Ini misalkan space sebab ini sama je dengan this part. Okay, so what happen is that the number of proton increase, so ZF kita pun increase. So the attraction between nucleus and valence electron pun increase. Tapi the different dia, the ionic radius decrease. So, dekat sini, as we can see, the ionic radius tu decrease. So, maknanya, contohnya ni, for example, for our sodium ni, contohnya lah. Oh, dekat sini dah bagi 20. Ini is actually the mass number ke? Okay. So, here is actually, contohnya kita bagi 31 ke. So, sini, contohnya 28. So, here is 25, etc. So, we know that when the, across the period, when the more positive the charge, the smaller the species. So, inilah maksudnya, sodium is bigger than magnesium. Magnesium is bigger than aluminium. Silicon is bigger than, and aluminium is bigger than our silicon. Okay. Ataupun, you could also write it down as, contohnya, kita buat kat sini Kalau kamu nak buat increasing atomic radius, increasing ionic radius. Okay, yang ni terbalik pula. Increasing. So, increasing ni means yang paling tinggi mana? Yang paling high, dia punya, the bigger atomic size is sodium. Second highest is actually magnesium 2+. Lagi. Lepas tu, aluminium 3+. And the smallest one is considered as I4+ lah. Here is actually increasing ionic radii. Yang ini in terms of, yang ni sebenarnya, dia punya arrangement ni yang decreasing. Sebab makin lama makin kecil kan ionic radii kita. Okay. So, kalau increasing, dia terbalik pula. Okay, so that's for the case of sodium to our silicon. So, right now, kita tengok pula between our P3-, our phosphorus to our chlorine. Okay, so sama juga from here. What happened is that from our phosphorus to our chlorine, the proton number increase. So, ZF increase. Okay, so the attraction between the nucleus and valence electron pun increase. So, ionic radii dia decrease. Okay, so it's either this one, you're gonna write down yang in terms of yang macam ni. Yang apa ni? Bigger than. Kalau case ni kamu nak buat contohnya P3-, S2-, Cl-. Ni is actually, again, this is decreasing. Decreasing ionic radius. Okay. Tapi, kalau dekat sini, kita boleh juga, kalau nak buat increasing ionic radius, maknanya yang terbalik lah. Maksudnya, from Cl- jadi S2-, jadi P3- ni, it's actually increasing atomic radii. Okay. So, if you be unsure nak buat yang, apa ni nama dia? If you don't want to write down bigger than, smaller than, you could also just write down your, apa ni? You could also write down comma and then just write down lah. Draw the arrow as well. Increasing ataupun decreasing ionic radii. Okay, so that's for the case of period 3. Okay, tapi belum habis lagi. Nak discuss sikit saja lagi. Tinggal, kenapa Y from Si4+ until P3- ni, tiba-tiba dia naik dekat sini. Why? Okay, so I've mentioned before, all the cations, ni tak mention lagi. All the cations have ionic radius smaller than an ion in the same period due to the shielding effect. Okay, sebab bila kita tengok dekat sini, our silicon 4+ is, the number of n is n equal to 2. Dekat sini, n equal to 2. Tapi dekat sini, kalau our phosphorus, n equal to 3. So if the number of different is different, if the number of n is different, we're going to be discussing in terms of n SAS. N number of shell, S is shielding effect. So between these two, what we will be discussing is that P3 minus actually has higher number of shell compared to Si4 plus. Hence, our phosphorus ion has higher shielding effect than silicon ion. So the attraction of nucleus towards valence electron in phosphorus is weaker. Sebab shielding effect, so maknanya repulsion tu is stronger lah. So attraction between nucleus dengan valence electron is weaker. So that's why I will say our phosphorus ion has a bigger ionic radii compared to our silicon 4 plus. Okay, so that's actually the end of our ionic radii. So we have learned about the anion and cation here, and then we also have learned about the isoelectronic species and the trends of the ionic radii across period 3.